Hey guys, welcome to the video. Today, I'll be talking about YOLO, You Only Look Once, Object Detection and Convolutional Neural Network. A simple explanation of YOLO is just giving a computer the ability to see. Now, teaching a machine to see the world is not an easy task. It's not as simple as connecting a camera to a computer. It takes a fraction for us to see, identify, analyze, classify, and finally act upon our vision. For example, if someone throws a ball at you, you identify the ball, analyze where it's going to go, and you catch it. But for a machine, reacting to human vision isn't just one action. It's actually a set of them, and it's called computer vision. It's a growing and ever-changing computer science field that is focused on how to make computers that can be made to perceive the world as a living organism on Earth would do. Today, in this video, I'll explaining what is YOLO, how it works, and how we can implement YOLO to our everyday lives.
So, let's begin with the basics. What exactly is YOLO? YOLO is a super popular form of object detection because it achieves high accuracy while also being able to run in real time. The algorithm only looks once at the image or video in the sense that it only requires the image or the video to pass through the neural network once to make predictions. With YOLO, a single convolutional neural network simultaneously predicts multiple bounding boxes and uses class probability to determine what the object is. So, how does it exactly work? This is a really good example on how YOLO determines objects. To put this simply, you take an image input, split it into an x by x grid, in this case 7 by 7. The image is then turned to grayscale, so the computer can process it as 0 and 1. As if it was RGB, it would be a lot more complicated. Each number is how bright that pixel is, and then we apply a filter. A filter is basically an area in which we multiply the numbers by another number and add all of the products together. In this image, we look at one part of the image, apply a filter, and sum the result to get a convolved feature. This makes it a lot easier for the computer to identify images. Now, all we need to do is train the YOLO convolutional neural network to learn and determine the final detection output by looking at these numbers. This is called the weights of the program, and the weights are made by creating a gallery of photos and what they are, and training the AI to recognize them. These galleries can contain up to 1,000 plus photos. This is only the first step, and it's only detecting the object and not creating the boundary boxes. The next step is to calculate the bounding boxes using IOU, intersectal reunion, and NMS, non-maximum suppression. The IOU is how well the machine is predicting the bounding boxes and matches up with the actual object's bounding boxes. Take, for example, the image of the car below. The purple box is what the computer thinks is the car, while the red is the actual bounding box of the car. The overlap of the two boxes gives us the IOU. Now, we're finally on our last step, the NMS. Object detection algorithms often have the issue of over-identifying a certain object. Here is a good example of the problem. Right now, the object detection is detecting multiple bounding boxes for a person. This is where NMS comes in. NMS ensures that we identify the optimal cell among all of the boundary boxes by giving a percentage on how sure it is and chooses the most likely one. Utilizing both IOU and NMS, it creates a prediction of the various objects in an image extremely fast. This is why YOLO is so much more heavily favored than other types of computer vision. So, what are some potential uses for this object detection system? One great example of how this technology can be implemented in real life is in self-driving cars. By implementing a YOLO algorithm, the car will be able to quickly identify people or cyclists. With other sensors to detect how far away they are, the car is able to take the necessary action to stop or avoid. This can also be used to detect road signs and lines on the road. Currently, YOLO is already being used to detect cars, people, and traffic lights. Thank you so much for watching this video. I hope you enjoyed.